Yeah.
So, good evening, everyone, and a warm welcome to the third webinar of our special four-part series celebrating World Space Week 2024, which is hosted by National Space Society USA Mumbai chapter. And we are so excited to have you here today. This series focuses on incredible potential of our space technology, which is addressing the urgent challenges of climate changes. And today's session is no exception. We are honored to have Dr. Mahesh Pathakodi with us, who is the scientist from ISRO, currently in NRSC, to discuss the space-time variable of greenhouse gases and its connection to India's unique climate dynamics. He has completed his PhD from IIIT Hyderabad, and he will be guiding us today through the different phases of climate changes and what are the effects we are having due to it. So over to you, sir.
Thank you, Anna. Thanks for your wonderful introduction. And good evening, one and all. As Anna has already introduced, myself, Mahesh, working in National Remote Sensing Center, one of the lead organization of Earth observation satellites tracking and the development of the Earth observation-based products and disseminating to the different users and ministries. So I'm working as a scientist in the National Remote Sensing Center, ISRO, Hyderabad. And my area of research is the remote sensing, ground-based, and also the modeling simulations or climate-based model simulations on greenhouse gases as well as the air quality. So today, like the World Space, first of all, welcome you all for the World Space Week. Every year, the UN celebrates between 4th to 10th October. So this year, this theme is very apt for my research, what I'm doing since last 13 years. I joined ISRO in 2011. So this theme is very apt to me and I'm working in this field. So the climate change, as you all aware that the extreme events that we are facing in terms of floods or droughts, and also the rapid growth of rapid increase of greenhouse gases. So today I'll be touching upon some of the aspects, the important aspects of greenhouse gases, and also their variability over the Indian region, and what is the current status of these monitoring of these greenhouse gases using space-based observations, and also the efforts put by the different ministries of Indian agencies as well as ISRO, how these observations are measured or also monitoring and also providing feedback to the government. So my topic is space-time, that is spatio-temporal variability of greenhouse gases. Especially, I'll be touching upon carbon dioxide, methane for the Indian perspective. So the climate change, like as you're aware that the climate change is because of basically two causes. One is the natural influence, the other one is anthropogenic influence. Natural influence, it always has its own balance because the volcanic eruptions which occurs rarely, or also the effect which we see in terms of air quality is a temporary effect. And also the natural effect of the climate change is change in the sun solar radiation, that is the sun intensity basically. So every 11 year solar cycle there is a change in intensity of sun's radiation, that is due to the intensity of sunspots activity. So that changes every 11 years, once in 11 years, but it has its own balance because it's a natural cycle. But the major phenomena that is happening due to the anthropogenic influence, that is human made, the contribution for the today's climate change what we are facing. So that is due to the rapid industrialization, which has begun in the revolution has begun in the 18th century by burning of fossil fuels, cutting down the forest, also the increase of forest fires, also the farming practices and the livestock. So these are the things like we use the fossil fuels for the most of the energy related sectors, because today the one of the largest contributor in the anthropogenic sphere is the energy sector, which we use mostly the fossil fuel sources for generating the energy. So these are the things which are majorly driving for the climate change what we are seeing today. And you know that the climate change is a change in the weather parameters over the period of 30 years minimum, and the effect is seen as a large, but whereas weather is the instant phenomena that happens within few days to weeks. So the climate change, to understand, to give the information, useful information, and also to support the decision making people, which we need to, which should be supported by the at least 30 years of information, and also to prepare for the mitigation. So major drivers which are contributing when it comes to the burning of fossil fuels are the anthropogenic era, are the increase of greenhouse gases, especially the CO2, methane, nitrous oxide, that is N2O, and carbon monoxide. Along with that, there are other secondary greenhouse gases like ozone, which acts as a bad ozone in the troposphere, as well as act as a good ozone, the pollutant in the stratosphere, because the ozone in the stratosphere protects us from the ultraviolet, harmful ultraviolet radiation. But whereas in the troposphere, it contributes as a greenhouse gas, because which is part of the global warming, which absorbs the radiation which comes from the top of the atmosphere. And also aerosols is nothing but the suspended particles in the atmosphere, the small particles which are having the dimension of less than 1 micron to 10 micrometer, and which has having two properties, like the absorbing property. The aerosol, that is a particle which is having the absorbing property, will have the warming effect, that is a negative effect on the earth's surface temperature, whereas the aerosol which is having the scattering property, which will have the cooling effect on earth's surface temperature. So these are the two types of aerosol, having the behind the physics of aerosol properties, like scattering and also absorption. And nowadays, not nowadays, like the LULC, land use land cover changes, is also introduced or highlighted in the IPCC reports from the AR5, that is annual report, assessment report 5, to till the assessment report 6. Land use land cover, the changes in the land use patterns, also the practices that we are using, the land use are changing, are also contributing for the emissions of these GHGs in the atmosphere. So there was a myth whether the climate change is really happening around the world, and it is proven by the Manabe team when they won the Nobel Prize award for for their simulations of global warming, and also they have used the climate models for the simulation of the global warming, which is caused by the greenhouse gases. So this has evidence that this is no more a myth, and it is its contribution is evident, and it is 100% that climate change is happening. And how it is happening, what is the role of greenhouse gases in this climate change scenario? Like as I just discussed, like at the top of the atmosphere, I'll not go into the details of the physics, what is this numbers and all, but the at the top of the atmosphere, the sun's radiation, that is the energy received at the top of the atmosphere, is 1368 watt per meter square. But when this energy transfer from the atmosphere to the earth surface, when it reaches to the earth surface, it is supposed to be 342 watt per meter square. But what is happening, because of increase of these greenhouse gases, because of the industrial activity, the burning of more fossil fuels are reducing the carbon sequestration, that is the sinks, which are the absorbing potential elements that we are removing because of the industrialization or the urbanization effect. So what is happening, they are because of these processes, the increase of greenhouse gases are increasing in the atmosphere, and which absorbs the incoming infrared energy. So when it absorbs, it also reflects back, and it also sends back to the earth surface. So the IR radiation, what happens when it is absorbing and re-emitting back to the space, also re-emitting back to the earth surface, it creates a heat. So that heat is proportional to the amount of these greenhouse gas in the atmosphere, which causes the energy deviation, that what we are supposed to receive at the top of the atmosphere to have the sustainable temperature around 18 degrees Celsius to 20 degrees Celsius. But because of this presence of greenhouse gases, the energy is getting altered, and as a result, we are seeing that Earth's surface temperature is increasing year to year. So that is the importance of this greenhouse gas, presence of greenhouse gas in the atmosphere, and the level of greenhouse gases, how it is affecting the energy which is deviated from the top of the atmosphere to surface. And to see that how as a proxy to the changes, proxy to the burning of fossil fuels or the use of anthropogenic sources, you see that the CO2 is one of the major emitting gas from the industrial activity or anthropogenic activities. During 1950s, the concentration was around 280 ppm, that is 280 parts per million volume. Given in the atmosphere, given a molecule of 1 million molecule of atmospheric molecules, if you this is the presence of 280 ppm presence of CO2. From 1950 to 2020 and also 2023, the concentrations are increasing per year 2 ppm. So this increase is an acceleration, indication of an acceleration of these activities. So and from pre-industrial to anthropogenic era, the concentrations have increased more than 420, 425 ppm. So now the annual global mean CO2 concentration have touched 425 ppm. So which is a really a very alarming rate of the atmospheric CO2, and this is a Keeling curve, popular Keeling curve, which first started the atmospheric CO2 measurements from the Mauna Loa site, which is a Hawaii island, and which is a global reference site for the atmospheric CO2 and other greenhouse gases. And if you see these greenhouse gases in the atmosphere, the radiative forcing, that is what just I spoke, like the energy deviated from the top of the atmosphere. When it reaches to the Earth's surface, we are supposed to receive 342 watt per meter square energy. But what is happening because of these greenhouse gases and other aerosols and other particles, the energy is getting deviated. So this x-axis of this box plot, if you see, this is the energy that is getting absorbed by these individual gases, and the y-axis is at a different altitude, different layers of the atmosphere. So CO2 is one of the major absorbing energy species, that is around 1.6 to 1.8 watt per meter square energy is getting altered by the presence of CO2 in the atmosphere. So this causes this contributes to the change of temperature 0.6 to 0.7 degrees Celsius. When we take the long-term average, the presence of CO2 alone is contributing for the 0.6 to 0.7 degrees Celsius changes. So then goes some methane. Methane is also short-lived gas compared to the CO2, but it has a warming potential greater than the CO2 when it compared to the 20 years of time scale. When you compare 80 years of time scale, it is a different the warming potential. But the warming potential of methane is more compared to CO2, and the abundance, currently the abundance also is increasing. The presence of methane is also increasing, and which is also contributing around 0.5 to 0.6 watt per meter square energy is getting altered by the presence of methane in the atmosphere. So this from zero towards right indicates the warming effect. The presence of these gases in the atmosphere creates the warming effect, whereas towards the negative scale, the presence of these particles or gaseous indicates the cooling effect. So there is an imbalance between the warming effect, warming agents, and the cooling agents. As a result, the positive effect we are seeing, that is the warming effect. And IPCC AR5 has also introduced, that is Intergovernmental Panel for Climate Change, which is a nodal agency under the UN frame. So which every 5 years the report is generated, the assessment report. So representative concentration pathways. So what does it mean by RCP? That is our representative concentration pathways. It is a metric to track the emissions with respect to the time scale. So here, if you see here a graph with x-axis are time scale and y-axis are emissions. So when we adopt some kind of the energy patterns, when we change, like when we adopt more renewable energy, or when we increase more fossil fuel burnings, what kind of energy is getting altered. For example, RCP 2.6 is the below curve which shows at 21st century, like the 2.6 watt per meter square energy will get altered with the concentrations around in the lower concentration. What exactly it means? So when you adapt more renewable energy sources, we'll attain the COP28 target, that is to limit the temperature, global mean temperature 1.5 degrees Celsius or less than 2 degrees Celsius. To achieve that, so we need to have the RCP 2.6 or RCP 4.5 the model. But whereas when we adapt towards more fossil fuel burning, the RCP 8.5, which leads to the the rise in temperatures in the order of 4 to 6 degrees Celsius, which is very costly when it comes to the adaptation strategies. So this is how IPCC AR5 has introduced track these emissions and to also to measure the what kind of the mitigation strategies we need to adapt to achieve the COP28 agreement 1.5 degrees Celsius or within less than 2 degrees Celsius. So these are like mostly driven by the natural sources versus anthropogenic sources. So it depends based on the how much amount you're burning the how much amount you're using the anthropogenic sources or how much you're adapting towards the natural sources. It will decide the RCPs towards the 2.6 to 8.5. So is also as part of this discussions, carbon removal has become the one of the essential discussion points in the COP28. So that is how like the carbon neutrality from India 2040 and 2070 net zero achievement is also India has planned. So climate finance, like some of the countries, like we need to provide the climate finance also to bring more awareness, also to adapt for the mitigation for the different countries based on the emissions. And what kind of risks when we see if you don't adapt the climate mitigation protocols, and if you adapt, what kind of scenarios we see that. So there are some of the parameters you see that like biodiversity loss. When we achieve 1.5 degrees Celsius temperature, global mean temperature, so we will try to lose the 14% of the biodiversity. But when you increase 2 degrees Celsius, 3 degrees Celsius temperature, this is going to be 29%, 18%, and 29%. And drought scenario also, like the people get affected by 0.95 billion people if it is a 1.5 degrees Celsius. But if the temperature increases to 2 degrees Celsius or 3 degrees Celsius, 1.25, 1.15 to 1.29 billion population will get affected. Similarly, see, even the forest fires, the other fires, agriculture residue burning or burnt area will also increase with respect to rise in with respect to the temperature rise. So if the temperatures are increased by 3 degrees Celsius by adopting the more fossil fuels, then you see 96 to 180% of the forest fire occurrence will happen. And now today we have the source versus sink, like even as we discussed already, like some of the sources like the industrial activity, also the cutting down of forest, together like 86% mostly is coming from the anthropogenic activity, that is the industrial activity, burning of fossil fuels, and whereas from the forest cutting down of forest 14%. But sinks, natural sinks are like ocean takes around 23 to 25% of the carbon absorbed by the ocean, and the forest also sequester around 29%. So these numbers are the simulated by the models, the global climate model. But however, you see the source versus sink, there is a uncertainty of 4% imbalance is observed. So still there could be unidentified sources or unidentified sinks, which still the models also need to be addressed. And also sometimes the model uncertainty also will cause this imbalance. So there is a difference between sources and sinks, which currently the global climate model experts are addressing this issue also. And current status of remote sensing. Oh, sorry, this slide is in PDF. So the yeah. Actually, we have the remote sensing technology has also improved a lot from 1996 to 2024. So there was a spatial resolution once upon a time. There was a spatial resolution of 300 kilometer. But today now, if you see around 2020 2021 period, we could able to achieve the spatial resolution of 30 meter to 60 meter with the constellation of different satellites. So from satellites in the vertical y-axis. So EDIOS satellites, it was lost for a few months, but now the GGSat, which is a commercial satellite by the Canadian, so it is a constellation of satellite which are put in the orbit, around 9 to 12 satellites, which generates 30 meter spatial resolution. There is one more sensor which is on board ISS, International Space Station, which is also giving it 60 meter by 60 meter spatial resolution. So it is indicating from regional scale mapping of carbon dioxide, other greenhouse gases to a point source identification, point source level of point source identification of CO2 and other greenhouse gases has improved from over the period of 20 to 30 years. So the remote sensing technology has become a powerful tool to monitor from global level scale to the point level scale using different sensors platform. And also now the researchers have also adopted the integrating these technologies like in situ measurements, also airborne measurements and satellite measurement all together, and also the climate models. So it's an integrated approach to address the global issues. And this globally, by understanding the importance of carbon dioxide in the atmosphere, so this is the global network and the global efforts, and by different research institutes and the agencies are measuring across the globe to measure the atmospheric CO2. And this is India's longest continuous atmospheric CO2 over Shadnagar region, which is measured by the NRSC ISRO, and this is the first of its kind over the Indian landmass, having the continuous long-term observations on CO2 as well as methane, and still these measurements are going on till today. And this is the observations measured by the ISRO at different locations, and the locations are also selected based on their land use, land cover characteristics, and because every land use, land cover will have its own signature for the emissions of these greenhouse gases. And to monitor the atmospheric CO2, we need to have kind of the strategy based on observations, because observations are costly, and when it comes to have a large network of observation, it involves a huge investment. So that is why we need to observe, we need to integrate observations, and we need to use the models, the climate models, which goes in which the data goes from the satellite as well as observation, and also inventory, that is a top-down approach, and also the bottom-up approach. So top-down approach, mostly the data comes from the satellite, whereas the bottom-up is the data generated using the kind of the emission sources on the earth, on the surface activities. So when it comes to in situ observations, we have a varied sensors to measure the atmospheric CO2, and space-based we have atmospheric infrared sounder and GOSAT, greenhouse gas observing satellite, which is by the JAXA, and also the orbiting carbon observatory by NASA. And also there are models we are currently using. We are also dependent on some international agencies like GEMSTIC. We are using this model, atmospheric chemistry transport model MEROC 4, for simulating the atmospheric CO2. And FlexPart is the one of the model to trace the sources, and also to see the dispersion from the source, how these the emissions are dispersing to different location. And also the fluxes, as I mentioned, like the global fire emission, the fire emitted carbon, how much fire emitted carbon, to study that there are the inventories, fluxes also, computed fluxes also available. And this is the approach which has been improved currently, like geospatial technology for climate research. So as I mentioned earlier, as I touched already, like ground-based observations increased across the globe as well as India. So airborne data is also like the surface the difference between ground-based observations and the airborne data is ground-based observations will give at particular altitude, but whereas airborne data will be able to understand at different altitudes the mixing of these greenhouse gases, how it is getting mixed at different altitudes, and the dynamics. To understand the dynamics, the vertical information is very much useful. Also to validate the satellite retrieved products, basically the CO2 and methane product. And this airborne data is also very much important when we fine tune the models. Basically the climate models needs the high accurate observational data from the ground as well as airborne data besides the satellite data. And satellite data, anyway, it has become more powerful tool to see the regional level to global level. Also, some of the satellites, as I mentioned, the GHG-SAT, which has come to the point level detection of the CO2 and methane. Along with that, to identify like the meteorology, like wind speed, wind direction, temperature, humidity, they will also have a significant impact on the movement of these greenhouse gases. So what we do, along with these parameters, we take the ancillary parameters of meteorological information, and also the fluxes, which I mentioned in the previous slide, fluxes, basically the top-down and bottom approach generated fluxes. And these data at varied scales and varied levels, this data will be integrated to the climate models as well as the transport models and also the regional model, which will be run by the climate model experts at fine grid resolution depending on the demand, and also the coarse grid resolution depending on again the need. So when we go for the fine grid resolution, basically the sub pixel level or sub pixel level, so we'll be able to resolve the information and to identify the what kind of activities happening at a given location, and to identify to know the regional level the effect or regional level activity. We can go for the coarse grid resolution climate model. So what happens when we run these models, what we are going to get when it comes to the CO2 perspective or the methane perspective. So we'll be able to identify the GHG emissions, that is the greenhouse gas emissions, especially CO2, methane, and their hotspots. So hotspots are nothing but the activity, the more concentrations compared to the neighboring areas. So when hotspots are there, it indicates there is some kind of activity happening. So what is that activity? So to identify that and also to assess that the level of activity, so we'll be able to identify those hotspots and emission, and and in which we need to identify their patterns also, like how it moves over the time. Spatial patterns, it may not be same every time, and it will have its own seasonal behavior and annual behavior. So it is very important to identify the spatial patterns, because as I mentioned, land use land cover is also playing a significant role in the GHG emission. So when we change the land use land cover, the spatial patterns of greenhouse gas also will change, and in turn it will help us to assess the regional to understand the regional carbon cycle as well as the global carbon cycle. And this information will help the policy decision makers to negotiate on climate change activities, also to take the informed decision to contain these emissions, as well as also to adopt the mitigation strategies. And as I mentioned, like we across India, also across the globe, we are measuring the surface-based observations of CO2. But there is one more the technology which measures the ground-based. It is a ground-based remote sensing technique. Like the satellites, basically now we all know that the satellites are measuring from the space to the ground, but there is a setup to measure the ground to the space. That is a ground-based remote sensing equipments, the ground-based instruments, which also measure the columnar CO2 using ground-based FTIR spectrometer, that is Fourier transform infrared spectrometer. Basically, these greenhouse gases, they absorb radiation in the infrared region, and based on their absorption depth, we estimate the concentration. So there is a different algorithm to how we estimate the concentration, that is called line-by-line radio-to-transfer algorithm, which I will not go into details. It's pure physics. So this, and if you can see this image, so there are some of the observations are scanty over different regions. In India also, before 2021, before 2013, there was no observations over Indian region to measure the ground-based remote, based on ground-based remote sensing measurements of columnar CO2. So ISRO has established ground-based FTIR spectrometer at National Remote Sensing Center, Hyderabad. I mean, the installation installed at Shadnagar campus, and this measures the almost 10 greenhouse gases during clear sky days, because this instrument only operates clear sky days, and sun is the active source to measure the greenhouse gases. And how it is important when it comes to the one point location, because the satellite based observations also needs ground based observations to validate and also to remove their uncertainties in the retrieval algorithm to generate a high quality CO2 product. So the ground based observations will act as a decisive for removing the uncertainties from the satellite data, and the further satellite data can be used entire regional level to global scale. So this information is very much important to address the uncertainties involved in the satellite data. Also, the long-term observations of columnar CO2 will also help how the dynamics of columnar CO2 is changing compared to surface CO2, because surface CO2 are largely influenced by the activities on the surface characteristics, but whereas the columnar observations are not much influenced by the above boundary layer activity, in which even the surface characteristics are the more contribution, but also the boundary layer which is the atmospheric layer, which will not have any impact on columnar observations. And this is the setup that we have at our Shadnagar campus, NRSC. And this is the typical spectra of infrared spectrometer, wave number versus the intensity. And these are some of the absorbing bands where we retrieve the greenhouse gases, especially CO2, CH4, water vapor, nitrous oxide, carbon monoxide. And this is the setup that FTR spectrometer looks like. This is the setup, it looks like this. And also we augmented with the portable spectrometer so that at a different location, because it is at one point location, but to have observations at a different location. And this is a suburban region where we measured from where we are measuring from the Shadnagar. Shadnagar is a suburban region, but having this portable instrument, even we can go to the urban region and see that how much anthropogenic activity really contributing for the CO2 emissions. So we have a strategy to measure at different parameters, and based on that we will be able to apportion the sources, what kind of activity is happening. And this is the data and result that we obtained from the portable spectrometer. And this is a columnar CO2 measured from on the FTR spectrometer. These are typical spectra which I showed. And as I discussed, like this data is very much helpful to validate the satellite product. So what we did, we have validated the Sentinel-5P tropobeam, which is one of the high resolution satellite currently available, which is at 5.5 by 7.5 kilometer square resolution. And this data we have validated using our ground-based FTR spectrometer, and whatever the bias we observed, which was adjusted in the satellite product, and we used the satellite data to understand the how the methane is changing over the period of time. And also there is a urban suburban interaction, like as I said, along with the greenhouse gas observations, we need to have the urban suburban interaction. We need to have the meteorological information, how much effect is caused by the greenhouse gases which are generated by the urban region, and how it is affecting the suburban region. So these kind of radius analysis we carried out to see that urban suburban interaction, and identified the activity which is causing these emissions. Also, the fire activity is one of the prominent seasonal activity which causes the elevated CO2 in the atmosphere. So we have used high split trajectory model, and to identify the at Shadnagar how much CO2 is elevated during different season. And we studied that at a different pre-monsoon generally we see more forest fires, and also the stubble burning we see during the post-monsoon season, at particularly northwestern region. So that shows that there is an enhancement of 2 to 4 ppm during these two seasons because of the fire activity. And also at this particular location, terrestrial biosphere, that is the sequestration of carbon is more dominant than the influence of anthropogenic during the monsoon season. So this is how we apportion the sources using the different techniques of observations, as well as the mathematical models. Like we have adapted the Melatone's model, which is developed by the NOVA scientists. So we use that model to identify the source activity. This is again talking about the source apportionment. I'll just skip. And this is a carbon emissions again from the biomass burning. Like these are a global fire emission database. We can see that which are the areas are more the biomass burning activities happening, and how much the carbon is getting enhanced during the active season of biomass burning. So biomass burning is also one of the anthropogenic activities, so which elevates the CO2 in the atmosphere. So this is a biomass burning emission database. That is a flux. We call that the bottom up approach method. And as I said, land use land cover plays a significant role in identifying the contributing the CO2 emissions at a different land use land cover changes. We divided entire India into 9 climatic zones, and this is the framework that we adopted to see that what kind of sources over different climatic zone. So the climatic zones are identified by the Köppen popular scientists based on the vegetation index, based on the climatic parameters, that is basically precipitation and temperature. So we use those 9 climatic zones, and we also the land use land cover classes were adapted to the 5 classes. Basically, those 5 classes are like forestry, agriculture, scrublands, and settlements, and all other classes are clubbed into others. So those 5 classes, how each class is contributing for the CO2 emission. So that has been studied using this framework in our recent research. And this is a database that we used to identify at different land use land cover what is the CO2 emissions and which class of land use land cover is contributing more to the CO2, and which class of land use land cover is acting as a sink. So in our study, this is the class that we adopted, built up as considered as a settlement, and different crops clubbed into agriculture, and other like forest, evergreen forest, deciduous forest. All these categories are clubbed into one forest criteria. So like that, we followed the approach which was set by the UNFCCC and IPCC, and also the National Communication NatCom. So we adopted this methodology to bring 5 classes from 18 classes to 5 classes, and to see that each class how it is influencing the CO2 emissions over the Indian region. And this is a spatio-temporal variability. And this color code, if you see, from 365 ppm in 2002 to 2022, it has touched 420 ppm, and it indicates a rapid increase of atmospheric CO2 in the atmosphere, about 53 ppm in last 21 years. So this is the indication of the activities that are happening in the country. Also and also we identified the hotspots. So some of the hotspots are identified in the Indo-Gangetic Plain region. Also some part of the higher altitudes, higher latitudes also seen that higher emissions of CO2 in the atmosphere. And each climatic zone will respond different growth rates, because each climatic zone have its own the activity based models. So we observed that each out of 9 climatic zones, the tundra climatic zone, which is the polar climatic zone, which is acting, which is seen the 2.3 to 2.4 ppm increase compared to other climatic zone. So indicating that tundra climatic zone is getting more activity compared to other climatic zones. So this is an interesting result that we observed out of 9 climatic zones, and the tundra is increasing at the higher rate of CO2 per year. And settlements have expanded in subtropical climate zone. One of the 9 climatic zones, one climatic zone has experienced 55% of settlements have expanded compared to other climatic zones, and also observed declining of agriculture by 3%. So this, and interestingly, and towards a positive effect, from 2010 to 2020-21 land use classes, forest growth is also increased, which is a good indication for the carbon sequestration. And this is the net primary productivity, which tells us the carbon sequestration, and whereas the bottom graphs will show the where are the hotspots of atmospheric CO2. So Indo-Gangetic Plain zones, which are densely for the hotspots for the CO2, and also the Western Ghats and Northeast zones are acting as a strong carbon sink for the over the Indian region. And this is what I mentioned, like India's longest CO2 record and methane record, which we are measuring continuously from 2013 to now. So this growth rate over Shadnagar region, which is increasing at 2.63 ppm per year. Also, methane is increasing at 17 ppb per year. So these sources of CO2 and methane are different. So basically, like when it comes to the methane, livestock, wetlands, and coal fields, thermal power plants, these are all the natural and anthropogenic sources. And the coal fields, cement production, and the burning of fossil fuels are more for the CO2 sources. And when it comes to the sink, the methane is 85 to 90% is removed from the atmosphere in the presence of hydroxy radical. That is purely it is a photochemical reaction. That is how the methane from the atmosphere is removed. But whereas the CO2 sequestration happens because of the active photosynthesis, that depends again the density of vegetation, Also the potential of the ocean uptake also decides how much carbon it can absorb. And now I'll also touch a few things about methane. So the GOSAT, this is a greenhouse gas absorbing satellite by the JAXA, and you see that from 2009 to 2022, the concentrations again have increased at an acceleration phase. The red indicates higher concentration, and in 2022, but the blue is a lower concentration compared to 2022. And this peaks in the 3D image. It shows the higher concentrations of methane areas. So the TROPOME is able to identify the zones which are contributing, which are releasing more methane to the atmosphere. So when we apply statistical filter, that is a 90th percentile statistical filter, the methane emissions are seen in the Indo-Gangetic Plain zone. And the further analysis, also we have done agroclimatic zones. This I'll skip again. So this agroclimatic zones also like in which we applied the statistical filter. It shows that agroclimatic zone, which are rice wheat based, the agroclimatic zone are zones which are adopting more on rice and wheat based crop culture. Then these are the areas where the rice and wheat based activities more, and also contributing are also observed high methane concentration over this zone compared to rest of the India and rest of the other climatic zones, agroclimatic zones. And this is further we dwell upon the point sources, that is coal, wetlands, thermal power plants, and coal fields. And the wetlands are one of the largest sources for the methane emissions when it comes to the natural sources. So in natural sources, wetlands alone contributes 31% compared to other sources. So to see that the extent of wetland area also depends on the atmospheric growth rate, because atmospheric methane, because of the microbial activity which happens in the wetlands, also in the soils, so that contributes to the release of methane. So we have also carried out about the thermal power stations, which is an anthropogenic source, and coal fields. And depending on the potential of energy generation, the thermal power plants, their potential or their capacity of the energy generation, the increase of methane is observed over these places. So 30 locations we investigated, and we observed that the more potential of more generation of energy is generating the more methane emissions. And this is a picture that to evidence the rapid climate change. See, from the latitudinal variation, so from 2009 to 22, if we see that the latitudinal variation from blue to red, so the concentrations around CO2 from 370 380 ppm to 420 425 ppm it touched. So it shows the acceleration of CO2 is increasing, and the acceleration of methane is also increased in the entire globe. So to contribute for the mitigation strategies, are also to monitor the over Indian region what is happening. So we as part of NRS ISRO's activities, we have established a dedicated observational network over different land use, land cover, and as a strategic location to see that how the CO2 diurnal and seasonally it is changing over different location. So we have established a dedicated ground-based observation network, flux towers, also the column measurements, as I shown that FTR spectrometer. We're also doing the source apportionment, like what kind of source, what kind of activity it is contributing for the CO2 that we are observing on the atmosphere. And as I shown that the potential of remote sensing technology, this is the EMIT sensor, which is on board International Space Station, which has the potential to detect the leaks at a particular industry. So this is how this particular region is able to pick up the higher methane concentration and its distribution over a given region. So this shows that the EMIT, also GHGSat, have demonstrated in identifying the point source leaks or point source emissions. So we are generating the data using ground based. We are generating the data using airborne data. We are also, the remote sensing technology has become powerful from in different levels, from point source to the global scale. So how this data will help, like we have a kind today we have entire globe have the earth observation, sensing of earth observations using different platforms like ground, satellite, and the models. So we are generating the climate data records, which is very important when we give informative when we disseminate the information which is useful for the policy decision makers as well as the common public. So this data will help. So we create a climate data record, that is CDR, then generate the applications, and which will help the decision making and also the mitigation strategies and also adapting strategies. And ISRO has also established a program called National Information System for Climate and Environment Studies, that is NICES program, to generate essential climate variables, which covers terrestrial, ocean, cryosphere, atmosphere. So WMO-based World Meteorological Organization has set the 54 essential climate variables through GCOS, that is Global Climate Observing System. So through that, 54 essential climate variables, which entire globe has to be globally all agencies, the responsible agents, to be monitored using the space-based observation, also supported by the ground-based observations, to generate the climate qualified product. So which these 54 products, the climate variables, covers all spheres of the earth, that is basically terrestrial, ocean, cryosphere, atmosphere. So under NICES, we are also generating different essential climate variables, and this is our architecture, basically the NICES, National Information System for Climate and Environment Studies. So we are also generating these climate variables. One can see our NICES portal. Just you can Google it, NICES portal. You will be able to get this information from the NICES portal, like what kind of product we are generating, and also we are also timely. We are giving the in situ observations for the public to use it. And some of the applications, seasonal applications like a hot weather outlook. So this during summer seasons, we generally give this product for the safety of the public, and they can see the product on the NICES portal, and one can take a informed decision. And these are all global climate variables. As I said, GCOS sets the 54 essential climate variables at different spheres, like all 4 spheres of Earth. So these are different climate variables like atmosphere, land, ocean, and cryosphere. So this we already talked about. And some of the products that, as I mentioned, we are also generating as part of our NICES initiative. So cloud product, cloud top temperature, and lightning activity. So ISRO has established almost 45 to 50 ground-based observational network, which continuously gives the lightning information. So one can see the data from the Bhuvan and the NICES portal. Also, the planetary boundary layer is a product is also important when we study the air quality, as well as using the long-term data, some climate applications. So the boundary layer information, the boundary layer dynamics also affect the atmospheric composition. So this product is also important. So we are generating this product also and disseminating through the NICES. And Bhuvan is also ISRO's geo portal, and many services are available covering from climate to the other user-driven the applications. So this can also be once one can take a glance through this portal. And as part of our climate research, climate activities, we have expanded our observations, our our limits, monitoring the GHGs. We extended our limits to monitor the GHGs in the polar regions also. So Arctic and Antarctic also, we are measuring the atmospheric CO2, methane, and because Arctic soils are the largest reservoirs of carbon. So basically the methane is stored, a lot of methane in the form of carbon is stored in the Arctic soils. So we are also as part of at different expeditions, we are participating and measuring these parameters and we are understanding how Arctic soil is responding or giving the feedback to the emissions of the methane and CO2. and Antarctica also acts as one of the the pristine environment, so disconnected from the mainland, and which gives the idea about the background information about these greenhouse gases and comparison with the mainland activity. So how much is the anthropogenic activity which is really causing the in terms of global warming also, and further the earth's surface temperature change. So this information really helps as a background information, and to assess what is happening on the mainland activities. And also we used ISRO's Avron aircraft to monitor the methane emissions from the hyperspectral imaging sensor. This activity was carried out as part of ISRO NASA collaborative efforts. So we used JPL NASA's every Senji payload, and we flew on our aircraft, and we could map the methane concentration over the different regions of different parts of the country. Sorry, there's some slides are repeating. So Bhunidhi is also one of the portals of ISRO and NRSC, where now even the geospatial policy, after geospatial policy, greater than or equal to 5 meter data, Earth observation data is made available. One can access and can use for different application. Even this data you can use for the air quality related studies, also to monitor the like aerosol parameters, also ocean related parameters, atmosphere related parameters. So this data is made available and disseminating through the Bhunidhi. So one can also go through this portal, very, very important portal when it comes to the data access. So we also touched how the climate monitoring from the space, so how it has improved from last 2 decades to now. It has become very powerful tool and very useful tool to monitor the near real time what is happening on the ground from the space. So air quality, and now we are generating data, so that's fine. So we have data based on the ground based satellite and model simulations or reanalysis data. So we are creating an we are using this architecture to generate a climate services. So the product is different and the service is different. So when somebody wants to see that what is the effect of the CO2, so that kind of information we are planning to generate in the near future as a climate service as part of our NICES program. So this is the ongoing activity, and in near real time we'll be seeing like how the Copernicus Climate Change Services C3SS is giving some of the climate services such as air temperature, sea level rise. So ISRO is also planning using India's Earth observation as well as the global Earth observation data to generate region specific and the global scale climate services products as part of our NICES activity. So the future strategies for space-based observations. So now we have all observations mostly in the polar synchronous orbit and also the geostationary orbit. And when we integrate all these, like a network of ground-based observations, airborne observation, and LEO low Earth orbit, the GHG-SAT, which is put in low Earth orbit, the constellation of GHG-SAT, CO2, methane satellite sensors. So those satellites, and also ISRO is developing the POEM, that is the PSLV 4-stage polar orbiting experiment module. So that is at PSLV, we call that a PSLV 4-stage, where we can put the nano satellites and micro satellites, which is a cost-effective satellites, which can be utilized to monitor some of the parameters on at surface related and atmosphere related. So this technology is also gaining momentum in the ISRO. So future this 4th stage of the PSLV can also be used for launching the small satellites. Thank you so much.
Thank you very much, sir, for this amazing information you provided us today. I request audience, if you have any questions, you can put it in chat or raise your hand. Sir, I guess you can stop sharing your slide.
No question, I guess. I think hopefully they understood.
Yeah, or probably some are typing.
Okay.
It was really a nice webinar. The topic is really interesting, and I guess we are doing a lot of work. As far I got to know with the webinar, I did not know at all that ISRO is spending so much on climate change until now.
Thank you, Pratmesh, and thanks to you and your organization for giving me this opportunity.
Thank you.
Sir, we have a question here. Can you let us know what kind of directions correlation that can be derived between forest fires and GHG fluxes?
Yeah, actually, yeah. So actually, the forest fires, as you know, that the forests are the large reservoirs of carbon, and they store the carbon in the stem, and the diameter of the stem depends the potential of storing the carbon. So this decides basically the amount of carbon storage or sequestration based on the health of the vegetation health. So when the forest fire happens, so the carbon emits from the because of the burning activity, the carbon is really getting emitted, and that emission it will add to the ambient levels of CO2, and it enhances the presence of atmospheric CO2. So the forest fires always is one of the important contributors of elevating the CO2.
Thank you very much, sir. One more question is there. Which data is used for monitoring Paris Accord according country-specific commitments?
Can you please repeat?
Sure, sir. Which data is used for monitoring Paris Accord country-specific commitments?
Paris? I'm not clear.
Accord country.
COP?
It's saying that person is saying Accord country. Even I'm not sure what this means. Maybe, sir, if you can clear your question.
Yeah, maybe the participant. Can you please elaborate your question?
Paris Accord.
What is the question? Which data used for monitoring Paris Accord?
Hello. So can you hear me?
Yeah. Can you please elaborate your question?
So we have this Paris Accord, right, sir? After COP28, there are these for the 1.5 degree global goal of mitigating the temperature rise. There are country-specific targets which have been set, and I believe there is a monitoring system to see whether countries are adhering to their commitments.
Yeah, actually, yeah, that's a good question. Like, so what happens actually? So there is a NATCOM in India, National Communication, and also you are aware of MOEFCC, Minister of Environment, Forest, and Climate Change. So we have to provide. Each country has to provide their emission factors from the different. Basically, like as I mentioned in my presentation, also there are major 5 classes which COP is also interested. That is agriculture, forest, and settlements, and grassland, scrubland, and grassland, and others. So each sector, how much it is emitting or how much it is sequestered. So these numbers required by the national communication and also their respective countries, they generate and they submit to the IPCC and UNFCCC. And that is what, once the report is submitted to the UNFCCC and IPCC, this is what every time in the COP meetings they discuss. So based on that, the further commitments and also the towards the future roadmap is prepared.
Okay, sir. Thank you so much.
And some of the information, just to add, you can also monitor from the World Resource Institute or World Database also. You can get some of the information. And moreover, you can just read IPCC AR6 report, which will have everything.
Sure, sir. Thank you so much, sir.
I hope you are clear with that. One more question is, can Gen AI help in detecting and measuring climate change and GHG's fluxes?
Yeah, of course. Now, actually, the everything we are moving towards a hybrid approach, that is the physical model as well as the empirical models. So physical models, in the sense that the conventional climate models, what they do, they are always with the limitation of data and data assimilation techniques. Basically, the real-time data should go to the climate models, and also there are some other the physics some more parameters which are need to be fine-tuned to get a accurate simulation. But however, there is some uncertainties are involved. But there the AI model is improving. So the nudging of AI based and the physical model are really improving the climate prediction. So now the recent trend is going towards the hybrid model. So yes, of course, the AI plus conventional models are improving the climate simulations.
Thank you so much, sir. I hope that was clear. The next question we have, can both carbon dioxide and methane be considered as the part of GFG fluxes, where while correlation with the forest fire emission and any other pollutant can also be considered?
Yeah, yes, that is again a good question. Like yes, CO2, CH4, majorly like when forest fire happens, majorly it impacts on carbon dioxide and air pollutants, basically carbon monoxide, nitrous oxide, that is NO, NO2. So these parameters are really get affected because basically the carbon monoxide and the nitrous oxide is like carbon monoxide is unburned carbon. So because of this forest fire, these parameters are the dominant species which gets emitted by the forest fires. CO2, carbon monoxide, NO, NO2. Yeah, I hope that question is clear to the participant. I mean, my answer.
Yes, sir. Sir, I have one question from my side. Like, what are the biggest challenge we are facing in data accuracy right now?
Now the data accuracies have improved. That's what even in my slide I showed that earlier to monitor these parameters, especially these greenhouse gases or air quality parameters, resolution was a limited factor. So it was like 1 degree by 1 degree, 2 degree by 2 degree, once upon a time, like 300 kilometer by 300 kilometer. But now we are in the era of 30 meter. So you see the development from 300 kilometer to 30 meter spatial resolution we have come. And accuracies also have improved because the technology has improved and the kind of measuring sensors have improved. So we are on par with the old meteorological set. The some always for these parameters, WMO sets is some limits, some accuracy limits. So now even the space-based observations are well within the WMO recommendations for monitoring these greenhouse gases. Accuracies have improved a lot.
Okay, thanks a lot, sir. Here, Krishna is saying thank you, Dr. Mahesh, for this informative talk on the topic, and he's thanking you. We have one more question coming. I missed it. Okay. Why are countries taking so much time to adopt more renewable energy resources?
It is a country dependent decision. So renewable energy, I mean, just it's my perspective, like renewable energy is a long term plan, and some things are like invest today, like the cost benefit analysis. Even when you do that cost benefit analysis in the climate mitigation or adaptation, you invest today. So what is the benefit you get, whether it is short term benefit or it is you need to wait for long term. So it depends on country to country, and also it is driven by the economy of the country. So there are some decisions, I think, which is the country dependent. So I think we can't talk beyond that.
Thank you, sir. I hope that was clear. Are we having any more questions? I guess there are no more questions coming up. Thank you so much, sir, for this really informative webinar, and hope to see you again next time.
Thank you.
I request all the audience to, if you have if you are interested in such space webinars and more about knowing about space, then you can check our website for different kind of webinars, and we have more webinars coming up in this space week. So you can check out the details. The details are posted in the chats. Thank you.
Thank you. Thank you.